Hi everyone, welcome back to my channel and thank you so much for tuning in. So in this video, I will be solving a problem or a question from the Cambridge IGCSE Mathematics paper 42 of May-June 2025. Now this question was a bit challenging to most of my students who sat for this exam, and I would like to give an easy step-by-step guide on how to solve the question and arrive at the most accurate answer. So let's dive into the question. Now here it's question 27. Now question 27 is the last question of paper 42, where you're given the diagram given is a cube. And then on the right-hand side, the question states that the diagram shows a cube. Calculate the angle between the diagonal AP and the base of the cube, which is ABCD. Now, from this diagram, no dimension was given. The side length of the cube was not given. So, first and foremost, we have to assume that the length of side is equal to x. So I'm going to assume that the side length is x. So let's assume it's x. And of course, the length of side of a cube are all equal. So if AB is equal to x, then BC will also be equal to x. And then CP will be equal to x as well, because all the lengths are equal. And then we're going back to the question that says, calculate the angle between the diagonal AP and the base ABCD. The diagonal AP, I'm going to join point A to B. So let's join point A to B using a line, point A to P. Now, this is point A to P, line AP. Now, to calculate the angle between the diagonal AP and the base of the cube, which is ABCD, I will also have to join point A to C. Now, let's join point A to C, and this is AC. Now, having drawn point A to C, we can conveniently identify the angle theta as this angle, the angle formed between the diagonal AP and the base of the cube, which is AC. Now, this angle can be called angle theta. So, to calculate the angle formed, we need to find AC. We need to find the length AC in order to calculate the angle theta. So, I'm going to draw the triangle ABC. Let's have triangle ABC. Here is triangle ABC. Okay, we have this diagram on the left-hand side here as triangle ABC. I'm going to label the triangle A, B, and C. So the side length AB is x centimeter. Length BC is x centimeter. Now, for the right angle triangle, finding the length AC will be used by using the method called the Pythagoras theorem. So by applying Pythagoras theorem, we can actually find the length AC. Now, Pythagoras theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. So AC square is equal to x squared plus x squared. And of course, x squared plus x squared equals to 2x squared. Now, to find the length AC, we have to introduce square root on both sides. Okay, and AC will be equal to the square root of 2x squared. 2x, the square root of 2x squared can also be written as root 2 times root x squared. Now, the square root of 2x squared can also be written as root 2 times root x squared. And of course, root x squared is equal to x. So AC, the length AC, will now be equal to x root 2. So x root 2 will be the length for AC. Now, having calculated the length AC as x root 2, we can now go back to the diagram and consider the triangle A, B, and C in order to calculate the angle formed between AP and the base of the square. Now, to find angle theta, considering triangle A, B, and C, which of course APC is also a right angle triangle, I'm going to now consider SOHCAHTOA. Let's consider SOHCAHTOA. Now, from SOHCAHTOA, we can find a relationship between opposite and adjacent. And here from this triangle APC, opposite, CP is the opposite, which is x centimeter. And the adjacent is AC, which we've already calculated as x root 2. So if AC is x root 2, which is the adjacent, and CP is x, then tan theta equal to opposite over adjacent. And of course, opposite, CP, is x over adjacent, x AC. AC is adjacent, which is x root 2. So we have x root 2. Now, x divided by x root 2, x goes into x, that is 1. We're going to have just 1 over root 2 as the value for tan theta. But since we're looking for the angle, tan theta, theta can be found by finding the tan inverse of 1 over root 2. Now, the tan inverse of 1 over root 2 is equal to 35.26 degrees, which is approximately 35.3 degrees. So we have succeeded in finding tan theta, first and foremost, applying Pythagoras theorem, and then finding the relationship between opposites and adjacent from triangle APC in order to find angle theta, which is the angle between the diagonal AP and the base of the cube ABCD. So finally, the angle is 35.26 degrees, which is approximately 35.3 degrees. So with this, we've come to the end of the video. So don't forget to like, share, and subscribe to my channel. Thank you.